Hey students, it is Mr. Rich. Welcome to my Sunday night live Q&A. And I am ready to do some work with you on math. If you do have questions for me that you want me to answer tonight during our live session, you see my email there scrolling at the bottom. Feel free to submit a question that way. I'll also keep my eyes open on the comments here in YouTube. What I did want to start off, though, is I wanted to start off by talking about the ACT trigonometry problems. We do have an ACT coming up this Saturday, the 14th of February, and quite a few of my students are signed up to take that I've been working with. We also do have another ACT in our area, at least the St. Johns County School District does have one on, I think it's on Tuesday, February 24th. So some students are going to be taking a test back to back. And so what I thought we'd do tonight is take a look at what the trigonometry problems look like on the ACT. Now, quite a few students who are taking the ACT are also taking AP pre-calculus. So they're right in the middle of their trigonometry unit. So that's good timing for them taking the ACT, at least for the trigonometry type questions that they might see on their test coming up this Saturday. So let's review some concepts that you need for ACT trig questions. And the first thing that you do need is obviously you need to know SOHCAHTOA. So you need to know what the ratios are for sine, cosine, and tangent within a right triangle. And your teacher probably in geometry taught you this acronym SOHCAHTOA to help you memorize what each of these three ratios are for the three trigonometric functions. And the O and the H and the A, they stand for opposite, hypotenuse, and adjacent. So if I present you a right triangle that is 9, 12, and 15 on the two legs, 9 and 12, our hypotenuse being 15, then we define these trig functions by using ratios of the side lengths. And so if I talk about this particular angle being x degrees, then if I say what's the sine of that angle, it would be the opposite side 9, the opposite side length 9 divided by the hypotenuse length, which is 15. So cosine of that same angle would be the adjacent side 12 divided by the hypotenuse 15. And that becomes the cosine of the angle tangent opposite over adjacent, 9 over 12. So they do ask you some pretty basic questions on the front part of the ACT. As you all know, I think most of you know that if you've taken the ACT, the math portion now has questions 1 through 45. It is a 45 question test on the math section, and that they give you 50 minutes. So the time per question has gone up maybe a little bit because it used to be 60 questions, 60 minutes. Now it's 45 questions, 50 minutes. So not much of a change there. But what I tell students just before we get into this first trig problem is I train my students to think about the ACT math section where you've got questions 1 through 30 as the first part of the test, and then picture questions 31 to 45 as the second part of the test. Now, the reason I differentiate between 1 through 30 and 31 through 45 is by and large, as you move from questions 1 through 30, the level of difficulty on those questions is going to increase as you get towards question 30. But then when you get to questions 31 through 45, this is just roughly speaking, questions 31 through 45 pretty much are all hard. It doesn't really mean then that that you're going to see an increasing level of difficulty from 31 to 45. Maybe a little bit, but I really tell my students, think about it as they're all hard. So therefore, most of my students that are trying to get, say, into the upper 20s to a 30 on the math section, I'm training them to devote a disproportionate amount of time to 1 through 30, right? This is where their gains are going to be made, making fewer mistakes and being able to get more questions right on those first 30. Then when they get to the 31 through 45, they're going to be a little bit more selective on which questions they actually devote time to. So you do want to get your eyes on all of the questions. It's not like you want to run out of time and not get to those last 5. I tell them to be sure that you're looking at all 15 of these last 15 questions and picking the ones that are the best ones for you, that you feel that you've got the best chance to answer. And it is not uncommon for there to be some pretty easy, I'm not going to say easy, but pretty quick answers that you could, questions that you could answer towards the end of the test in questions 42, 43, 44, 45. So you definitely want to look at all of them, which means you may want to be skipping through quite a number of these at the end of the test until you get to the ones that you can answer. But now, this would be the kind of question. This actually comes from the old version of the test that when there were 60 questions. So this was in the first half of the test, and it was meant to be a relatively easy problem. It's saying, what's the value of sine of angle theta? Well, if you know that sine is opposite over hypotenuse, and it is, that's the ratio, then the opposite side from theta is unknown. Well, if you recognize this is 12 and 13, you should know that there is such a thing as a 5, 12, 13 right triangle. And so you know that this is 5 opposite over the hypotenuse 13. That is a very simple answer, a question that you should answer in relatively short order. Now, if you didn't know what that 5 was, you could use the Pythagorean theorem, right? You could say that x squared, that unknown side, plus 12 squared is equal to 13 squared. Solve that for x and you would get that side of 5. Okay, so pretty basic, straightforward problem. Now, let's take a look at one that might be a little bit more challenging. This would be one that you could expect to see in that second portion of the test, 31 through 45. And it does have a circle in it, right? And you may be thinking it's more of a geometry problem, but when you take a look down here, they're not going to give you values for sine, cosine, and tangent of an angle unless you're using trigonometry, right? So you know this is a trig problem. So this says that radius OA of the circle shown below is perpendicular to line segment AP. Okay, yeah, that's shown right here with this right angle. The circle intersects segment OP at B. Yeah, okay, so B is on the circle is what they're telling us. The length of segment AP is 12, right? That's marked on there. And the measure of angle APO is 20. Sure, I see it marked there. Which of the following is closest to the length in centimeters of segment BP? So they want us to find the length of that segment right there. Now, if you're not sure, how am I supposed to find that segment over there, that portion of the hypotenuse? Well, what I'm going to do is I'm going to find the lengths of all 3 sides of this right triangle. And it should make sense once I do that. Now, how will I find that? Well, I can't use the Pythagorean theorem to get any of these other 2 sides of this right triangle. I only know one side and I know one angle. I don't know the other 2 sides, this other leg and this hypotenuse right here. But that's where trigonometry comes in, because when we taught you trigonometry in geometry, it was for the purpose really of finding sides and angles in a right triangle when you only knew one side. So let's find AO, the length of AO. Well, the one angle that I know, 20 degrees, for which they gave me these trig function values. From that angle, this is the opposite side, and the one known side would be the adjacent side. So which trig function includes opposite and adjacent? Well, that would be the tangent function, right? TOA. When you think about SOHCAHTOA, you're thinking opposite adjacent. That's TOA. So I can write this relationship here. The tangent of 20 degrees is equal to the opposite side, which is the length of segment AO, divided by the adjacent length, which is 12. Just doing one algebra step allows me to solve this for segment AO. It's going to be 12 times the tangent of 20 degrees. Now, I'm not going to use my calculator here, right? I would have my my TI-84 pulled up right here, but I wouldn't. I definitely would not be using that here because they gave me the 0.364. So I know that I'm just going to take 12 times 0.364, and I'm getting 4.368. So I know that this other side is 4.368, and that happens to be a radius. Now at this point, I realize that segment OB would have to be the same length because it's also a radius of that circle. Now their question makes a little bit more sense, because if I get the hypotenuse from O to P, I could then subtract that known segment there, OB, 4.368, from the hypotenuse. It will give me the length that I need. Now, how am I going to get this hypotenuse? I'm going to just use the Pythagorean theorem at this point, because I know I have a leg of 12 and a leg of 4.368. So I'm going to go to my calculator, and I'm going to go ahead and put a square root on here. And then I'm going to add the two squares of those legs, 12 squared plus 4.368 squared. And that is going to give me 12.77, right? So that hypotenuse is 12.77. If I take away the 4.4, right, rounding that to 4.4, I'm getting about 8.3 or 8.4. So E is going to be my answer right there. Okay, so that's just using right angle trigonometry to solve a right triangle. All right, let's do one more of these. This also, notice that this is question 15. It does come from one of the earlier tests when we had questions 1 through 60. So this is meant to be a very easy problem. They're wanting us to, they give us all the information, but it's all marked on the triangle here. They want me to find this side. And notice, I know an angle. The side that I'm looking for would be the opposite side. The side that I know is the adjacent. So again, this is going to be a tangent relationship. So the equation is tangent of 50 degrees would be equal to the opposite length, which we're going to call x, divided by the adjacent length, 15. And so what I can do is multiply both sides of this by 15. 15 times tangent of 50 degrees would be equal to x. I will use their number here for tangent of 50. So I'm going to put 1.2 and multiply that by 15, and I'm getting an answer of 18. There it is. Problem solved. Now, one of the reasons why I probably would not use tangent of 50 here, and I would just use their approximation for tangent of 50, is that way I don't make a mistake of where if my mode in my calculator is in the wrong mode, right? I happen to be in degrees, so I would be okay to do tangent of 50. But if my calculator was accidentally in radians mode and I didn't check it and I did tangent of 50, I would get a wrong answer for tan 50. I will always use their numbers that they give me here in these trigonometric problems. Okay. All right, there we go. All right, I got more that I want to show you here about trigonometry, so hang tight. I'm going to show you more. All right, so again, if you're just joining, my name is Mr. Rich, and I am a math tutor here in Jacksonville, Florida. Every Sunday night, I do have a live math Q&A here on my YouTube channel where I will answer questions that you have. If you have questions that you want to send in to me, you can see my email scrolling there at the bottom of the screen, and I will answer your question. But tonight, we're starting off by looking at ACT trigonometry problems. All right, the other main problems that I wanted to look at tonight are law of sines and law of cosines. Back in geometry, there were two other formulas that we taught you about how to solve for sides and angles in triangles. And these were formulas that we used for triangles that are what we call oblique. Oblique triangles are triangles that do not have a 90-degree angle in them. And really, SOHCAHTOA, right, all of those ratios for sine, cosine, and tangent, they only apply to right triangles, not triangles that are missing a 90-degree angle. So, but there is a way to use trigonometry to solve these oblique triangles, and they are called the law of sines and the law of cosines. The ACT, that is very common to get at least one of those problems on your ACT math section. And the issue is really that most students who are taking like AP pre-calc, they're not covering that in the trigonometry unit. So you're not getting any exposure to the law of sines, law of cosines problems. You would have seen that way back in geometry 2 years ago, maybe even more than 2 years ago when you were in geometry. So if you don't prep for your ACT and go back and refresh on how to do these problems, you'll likely miss them. And really, they're relatively easy if you understand the formulas. So I wanted to work a few of those problems for you tonight. And that is exactly what we're going to do. All right, this right here is the law of sines. Right here, this is the formula. It looks weird. It's like 3 equals 3 ratios set equal to each other. What is it telling us? What this is telling us is that if you know one angle in your triangle and you happen to know the opposite side length, you can make a ratio of the sine of the angle divided by the length of the opposite side. And whatever that ratio is for that pair, for that angle side pair, it has to be the same for the other angle side pairs, which would mean that if you can set up this ratio, because you do in your triangle have an angle side pair, you could solve for one of the missing sides or angles. All right, so let me show you how that works and how you should think about these problems. All right, take a look here. This is question 59. Now, typically, these law of sines and law of cosines do occur towards the second half of the ACT math, like I was telling you. Right, you've got your first part 1 through 30, and then you've got the second one 31 to 45. They're generally on the harder section over here on those last 15 problems. Well, here they tell you that someone's flying a kite. There's some string attached to the kite. You know these two angles, right? There's a person over here at B looking up at the kite. There's a 45 degree. That's 75. So what they want us to do is find the length of that string. So what I'm going to do is I'm going to use the law of sines. Here's why. Because if I take a look at this triangle, since I know those two angles, I could add them together and subtract from 180 to give me this other angle. Well, 75 and 45 is 120. So I know that that's a 60-degree angle right there. Now, there's several ways that we can do this with special right triangles as well, but I'm going to solve this with the law of sines. Here's why. I do know this angle side pair. I know an angle of the triangle, 60 degrees, and I know the opposite side. So what I can do is I can make a ratio and say the sine of 60 degrees over 240 must be equal to, this is the side I'm looking for over here, the length of the string. And the angle opposite from that is 45 degrees. So I could say that that's equal to sine of 45 degrees divided by x. And then I can just solve that equation right there by cross multiplication. So I can say that if those two fractions are equal, it means that x times the sine of 60 degrees must be equal to 240 times the sine of 45 degrees. I'll divide both sides by sine 60, and then that's going to be the answer that I need. So I'm going to go ahead and take 240, multiply it by sine of 45, making sure that my calculator is in degrees mode. And then I will divide that. Let's expand this just a bit. There we go. Yeah, that's better. Sine 45, and then I will divide that by sine of 60 degrees. And we'll get an answer. And it's 195.96 or roughly 196. So probably not those. I'm going to convert those answers to decimals, right? 80 times the square root of 6. Yeah, there we go. That, in fact, notice I get the same exact answer there in a decimal format. So that's going to be the answer right there. Now, this one is kind of a unique problem because I think I could solve this by using special right triangles. Here's why I think that. I kind of forgot about this when I pulled this question for tonight. But if you go from here and drop a perpendicular to that line right there, what it means is that this is a 45, 45, 90 triangle, right? We knew that this was 60 degrees. And therefore, that makes this 30 and this one 45. So this triangle that I'm looking at right here is a 45, 45, 90 with a hypotenuse of 240. So what are the legs? The legs are going to be 240 divided by the square root of 2 by special right triangles. So this side, I'm going to zoom in just a tad bit more here. That means that this right here is 240 divided by the square root of 2. Now that is the long leg of a 30, 60, 90. That means that I could get this short leg by dividing by the square root of 3. So it's 240 square root of 2 divided by the square root of 3. And then to get from the short leg to the hypotenuse of a 30, 60, 90, you multiply by 2. So that would make this answer to be 480 times root 2 over root 3, like that. Now, what I could do is rationalize that by multiplying top and bottom by root 3. That gives me 480 times the square root of 6 over 3. Let's see, did I do that right? That doesn't look right. So if this is 240, that's 240 over root 2. 240 over root 2, dividing it by root 3. Oh, yeah, I see what happened. This is 240 over root 2 divided by root 3. So it actually becomes 240 over root 6. Yeah, so what you have here is this side right here is 240 divided by root 6. So then I would multiply that by 2 to get 480 over root 6, like that. And then when you rationalize this, root 6 over root 6, you get 6, you get a 480 root 6, and that 6 goes into 480 80 times, 80 root 6. Okay, but it probably is best solved, it looks like to me, by just using law of sines. But notice in this problem, they did not give you the formula for law of sines. So you've got to know the law of sines and the law of cosines, which I'll show you in just a minute as you go into this test. Okay, if you have any questions on that, put them in the comments for me. Checking to see if there's any math questions that did come in. Nothing yet, but let's go now down to the next one. The next equation is called the law of cosines, and here is the formula right here. Now, what I do when I train students to remember these formulas, because you do want to have these memorized, because you can expect one of these problems and you can't count on them giving you the formulas. They do sometimes they do not. And the best way really to memorize the formula, I find, is instead of using this format right here, you can call this c squared is a squared plus b squared minus 2ab cosine of c, like that. These are identical formulas, but this one is the one that I recommend memorizing. Why? Well, just because it starts off looking like the Pythagorean theorem. So that helps you memorize at least that portion of it. But then all you really have to memorize is the extra term back here that you're tacking on to the end of the Pythagorean theorem to make it into the law of cosines. And this is obviously a negative here, number 2, and then the product of these same two sides without the square, AB, and then cosine of angle C, which is the angle that would be opposite that side over there. Now, usually when you're using the law of cosines, it's a very familiar problem, because what happens is typically you know two sides of the triangle and the included angle, and you're solving for this side right here. And then you're using this formula. This side over here would be the one that you're looking for. The angle over here would be this angle here, and then the A and the B are going to be these two sides. So let me show you what this would look like. So it's a question 53 from one of the old tests. So it was given to you towards the end, meant to be a more challenging problem. They did not give you the law of cosines. However, notice that I have two sides that are given to me and the included angle, and they want me to get the distance from Dearborn to Fergus right here. So yeah, I know this angle and I'm looking for that opposite side. Now, the reason why I know that I'm not using the law of sines on this problem is, notice with the information that they gave to us here, we do not know an angle side pair. I know one angle and only one angle, but I don't know the opposite side. I know this side, but I don't know its opposite angle. I know this side, don't know its opposite angle. So there's no way at this point to use the law of sines, because you need to be able to make that ratio of a side divided by the sine of the opposite angle. All right, so it is a law of sines problem. So all I'm going to do to solve this for that distance there is say that that distance c squared is that side squared plus that side squared minus 2 times 80 times 120, right? I'm using the product of those same sides, but without the square. And then I would multiply that by the cosine of the included angle, which is 127. Now, to put this in my calculator in one calculation to streamline, I'm just going to square root both sides, right? Because if I square root the left side, I get rid of that square. So really, that's my calculation to come up with one of those answers. So going over to my calculator, I am going to put a square root there. And then let's just do it, right? 80 squared plus 120 squared minus 2 times 80 times 120. Notice I'm not putting any parentheses here because I know my TI-84 understands the order of operations. So I'm good to just put these multiplications right back to back. Hit equals, I'm getting about 180, and D is going to be my answer right there. Okay, students, I hope that helps on the law of cosines. So again, just to keep this straight, because I think that is the last one, the law of sines and cosines. Yeah. So I want you to frame it this way. When you come across one of these oblique triangles and you realize that you're solving an oblique triangle with either law of sines or law of cosines, you're first asking yourself, do I have an angle side pair? Because if I do, I'm going to use the law of cosines. If you don't have the angle side pair, then you're going to have to resort to using the law of cosines. All right, so I definitely recommend practicing maybe 5 to 10 of these problems so that when you see them on the test in questions 31 through 45, you know that that's one that you want to answer. That's one of those 31 through 45 that you definitely want to go get because you know how to do it. Okay, so I hope that helps. Now, there's a little bit more to that that you do need to know about trigonometry. And I'm just going to summarize it by taking a look at this problem right here. In this case, they're giving us a trig function, and it is a cosine function. So if you've taken AP Pre-Calc, if you're in AP Pre-Calc right now, more than likely you recognize that this is a cosine function. And they want you to match it to the right equation. So what you have to know about cosine and sine functions is you need to know that this number that's in the front of the cosine or the sine function is what we call the amplitude. It is the distance from the middle line, right, that cuts the function vertically in half. It's the distance from that line to either the maximum or the minimum value. So you can see that that's 3 units. So we definitely can get rid of F and G. Now, the other thing that we need to know is how to find the coefficient that you would put in front of the X. If you take a look at this right here, the period of a cosine function goes from peak to peak. And if that's pi over 2, that's pi. So I know that the period of this function that they're showing me on the graph is pi radians. And that coefficient, right, again, this is something that the pre-calc students, they understand at this point, that the coefficient that you put in front of the X inside the function is going to be 2 pi over the period. And if the period is pi, which we read off of the graph, we know that that coefficient here, 2 pi over pi, is going to be the number 2. Okay, now let's see what's going on here, because my period here is pi. So why is this x over 2? So the period is definitely pi. That is extremely interesting. So let's see. So this is going to be 2 pi over the period. The period is pi. So this should be a coefficient of 2. I'm not really sure what this is. So this should be y is equal to 3 cosine of 2x. Let's see if there's another. Oh, there's probably another answer. That's what it is. I did not scroll down far enough right here. Okay. And so, yeah, so that's going to be our right answer. I didn't scroll down far enough to see that that is 2x right there. Okay, let's see if we got any questions. No questions came in. And that's going to be it for tonight then, students. Next week, we're going to take a look at some more ACT questions. I'll have a special topic. I'll post that probably tomorrow on the YouTube channel, what the topic's going to be next week. I think it's going to be about matrices, right? So one of the things that students typically will see on an ACT is one, maybe even 2 questions about matrices. Most students, at least in our area, they've really not learned anything about matrices. So I will cover matrices, I'm pretty sure, next Sunday night. Okay, everybody, have a great week ahead, and I will see you next Sunday night at 8 o'clock.